Hi and salam sejahtera. Thank you to my panel for spending time to listen to my bachelor degree project presentation. And I would like to thank my supervisor, Professor Madia IRTS, Dr. Muhammad Yuhasri bin Yaakob, and my co-supervisor, Dr. Muhammad Amir Hafizan bin Hussein, for giving me a golden opportunity to do this project. And thank you for guiding me with passion and sharing knowledge to me throughout this research. First of all, my name is Anyie Tomy. I'm 25 years old. I came from Miri, Sarawak, and now I'm a third-year student from Bachelor of Manufacturing Engineering Technology. Today, I would like to present my project with title Research and Development of Fire Retardant Kena Fiber for Heat and Fire Insulator Application. For the presentation outline, I will cover 8 main points, which are introduction, problem statement, objective, scope of research, selected literature review, methodology, expected result, and lastly, expected conclusion. Nowadays, the use of natural fiber has become increased in industry due to the growing of need to conserve energy. Natural fiber is divided into 3 types, which are plant fiber, animal fiber, and mineral fiber. The development of natural fiber is an important opportunity to produce material from renewable resource in order to construct sustainable building. This is because natural fiber is eco-friendly material, low energy consumption, and has low cost production. Therefore, this study will focus on the use of natural fiber as the best material for thermal insulation application, especially in industry. The purpose of thermal insulation is to prevent heat loss and reduce energy consumption and achieve energy efficiency in construction. For this study, the type of natural fiber used is Kena fiber. Kena fiber, or hibiscus cannabinus, is an economically viable and environmentally friendly alternative fiber crop. Because of its lightweight, biodegradability, low cost, and a good mechanical properties as well as good thermal stability, Kena fiber was used as a reinforcement for composite. Fire retardant is defined as a substance that is used to slow down or stop the spread of fire or reduce its intensity. The advantage of fire retardant is it can stop heat from getting through and flames from spreading. Besides, it has no effect on the material's inherent properties. For this study, the problem statement is first, there is a lack of study about the use of Kena fiber in heat and fire insulator according to previous study. Nowadays, the cost production to develop thermal insulator is very high due to the increased use of synthetic fiber because it has a good mechanical properties. The high production use synthetic fiber in industry lead to environment issue. This is because synthetic fiber such as glass fiber is non-biodegradable material resource. Another problem statement for this study is natural fiber has a low mechanical properties compared to synthetic fiber. Most industry would prefer to use synthetic fiber due to its better performance. In this study, the intention is to observe and identify the problem that occur in the development of Kena as the best material for application, especially for thermal insulation in industry. Therefore, in order to maintain the quality of Kena fiber and increase the demand for it over synthetic fiber, an effective solution must be found. There are 4 objectives of this study. The first one is to fabricate Kena fiber with various fire retardant ratios loading for heat and fire insulator application. The second objective is to investigate the properties of Kena fiber with various fire retardant ratios towards high temperature. The third objective is to evaluate the effect of fire retardant on acoustical properties. And lastly, the objective is to recommend the best Kena fiber fire retardant ratios composition for optimum performance in heat and fire insulator application. The limitation of this research is to study the potential of Kena fiber to be used in industry by considering the mechanical properties and cost. This research also will identify the suitable amount of composition of Kena fiber and fire retardant to produce a good heat and fire insulator application. This study will ensure that the insulator able to withstand a high temperature up to 40 degrees Celsius. Moreover, Various testing such as thermal testing, fire testing, and acoustical testing will be made to investigate the relationship between kena fiber and fire retardant and their ability to absorb energy and resist heat or fire. These are the selected literature review of this study. According to Chen, thermal insulation is a useful tool for preventing heat loss and reducing energy consumption. A study by Chiki states that natural fiber is qualified to replace synthetic fiber for industrial application, especially thermal insulator, because natural fiber derived from a renewable resource, as it requires little energy to manufacture and easily dispose at the end of their life cycle by composting. In Monier's study, kena fiber is a type of natural fiber was used as a reinforcement for composite because of its lightweight, biodegradability, low cost, and good mechanical properties as well as good thermal stability. In 2007, Gu mentioned that fire retardant coating stops heat from getting through and flame from spreading and has no effect on the material inherent properties such as mechanical properties. This is the methodology of this research to develop heat and fire insulator application. The first step is preparation of raw material. This method is important in order to obtain the best quality of product. There are two materials used in this research, which are kena fiber and fire retardant. Kena fiber will be used as the reinforcement, while fire retardant will be used as the additive filler. Kena fiber was selected due to its fast-growing, high productivity, and suitable for being planted in Malaysia climate. Kena fiber was purchased from Lembaga Kenaf and Tembakau Negara Malaysia with the price of 2,200 ringgit per ton. The preparation of kenaf is, it will be cut into the length of 250 mm and make sure it is dry before mix it with fire retardant. Fire retardant was chosen to be the additive filler because it is one of the most efficient and cost-effective fire protection method to protect substrate materials against fire. The type of fire retardant that used in this research is instrumentation fire retardant coating, which is a water-based. A fire retardant with weight 5 kg and price of 320 ringgit was purchased from Lazada. According to the product feature, it is 100 times thicker than the original coating and a strong heat insulation effect as it can withstand up to 1000 degrees Celsius. For the surface of metal, it resists up to 120 minutes and wood resists up to 90 minutes. Before applying it, the surface of the sample must be completely clean and dry. Moreover, the surface temperature must be at least 3 degrees Celsius above the dew point to prevent condensation. Next is the preparation of the mold. The dimension of the mold is 250 length, 250 width, and height of 10 mm. The reason of this measurement is to ensure that the sample of this testing is adequate amount. Material used to fabricate this molding is rubber wood due to their availability in market. In order to avoid the sample sticking to the molding, polyvinyl chloride PVC will apply. Next is fabrication process. In order to obtain a layer of layout, kena fiber and fire retardant is mixed up together. First, pour the fire retardant liquid into a basin. Then, soak the kena fiber in the fire retardant liquid. This process will take around 24 hours for the kenaf to absorb the fire retardant liquid. The ratio for both kena fiber and fire retardant is based on the required design of the sample. The dimension will be 250 meter length and 250 meter width. However, the thickness of the layout is not fixed as it depends on the composition ratio of the kena fiber and fire retardant. Therefore, in this research, the thickness of the layout will be investigated in order to obtain the best thickness layout that is suitable to be used for pipeline in industry, and the important target is to follow the required standard. The next process is testing method. There are 3 methods will be used, which are thermal test, fire test, and acoustic test. The first testing is thermal test. This testing is to obtain the thermal conductivity of the sample, which is the ability of the sample to conduct heat and heat flow of the sample at a maximum temperature of 400 degrees Celsius. The target is to make sure the outer part of the sample is safe to be touched. This testing will use a guided hot plate method. The working principle of guided hot plate is first, the sample is placed between two plates. One plate is heated and the other plate is cooled. The temperature of the plate is monitored using thermocouple until they are constant. The second test is fire testing. This testing will use fire torch as the fire supply to shoot on the surface of the sample. The purpose of this test is to watch how a flame spread across a sample in order to determine the material relative burning behavior. The duration for this testing is 10 minutes and the distance between sample and the fire torch is 10 mm. Therefore, the evaluation will be the time taken for the sample react to the fire. The last test will be acoustic testing. The sound absorption coefficient was determined using an impedance tube method, and the result shows that as fiber content increases, so does the sound absorption coefficient. In this study, impedance tube method is used to obtain a sound absorption coefficient based on ASTM standard. The frequency range used for impedance tube testing is from 1 Hz to 5000 Hz. First of all, the first step is to calibrate the impedance tube testing. This step is important to ensure that the device works properly and prevents error during the test. Then, calibration is necessary to ensure that the results are accurate at the end of this testing and to ensure that it is safe to use before doing the testing. The next method will be the microscopic analysis. Scanning electron microscope (SEM) is used as the instrument to examine the sample to identify the sample morphological surface fracture of kernel fiber after heat testing and fire testing is done. The expected result for this research is that increasing the thickness of kernel fiber will significantly improve the insulator's performance. This is due to the delay of the heat transfer through the fiber. For the green element purpose, the application will be applied in industry to prevent heat losses and achieving good economy in energy usage. Kernel fiber has a low machine wear and a good biodegradable material as it can easily dispose at the end of their life cycle by composting, which is not possible for fiberglass. Kernel fiber also require a low energy input in their manufacture. Therefore, kernel fiber qualified to replace synthetic fiber in reinforcement of composite. For sustainability purpose, kernel fiber is an alternative to current heat and fire insulator because it has a low cost of production and renewable resource that can be easily obtained due to its shorter cultivation life cycle and ability to grow in variety of soil types, particularly in Malaysia. Then, using a good thermal insulation material reduce cost because energy loss is minimized and electricity consumption is reduced. As a conclusion, the expected to develop a good performance insulator application is achieved, where it able to withstand high temperature without spreading the hot temperature to surrounding. The sample with 40 weight% of kernel fiber and 60 weight% of fire retardant is expected to have the best composition ratios. From this research, a new knowledge of application of fire retardant kernel fiber for insulator application was achieved by applying eco-friendly and biodegradable product, for example kernel fiber, which is a type of natural fiber. That's all for my presentation. Thank you.